The AMSTRAD 464 is the 64K home computer with a monitor and data recorder included. From around $429, only our competitors aren't having fun.
Hello Internet! How are you all doing today? I'm really happy because I got a new toy. I got this AMSTRAD Color Personal Computer 464 from my friend and co-worker Torsten for free. Can you believe it? If you're familiar with this computer, then you may wonder why it doesn't have the colorful keys the CPC464 is supposed to have. And the reason is very simple. This is a German version of the machine distributed by SCHNEIDER and not one of the British models. But except for the differently colored keys and the missing AMSTRAD logo, the machine is absolutely identical to the original. As you can see, it has actually collected quite some dust, and my friend seems to have replaced the power switch at one point in the past. Other than that, I'm told it works perfectly fine, so I'll take his word for it and just power it up. My friend was also so kind to lend me his TV modulator. Originally, this computer came with a monitor that is also the power supply and has a special plug for the CPC's video output. But the monitor got lost in the sands of time, and so I'm here with this TV modulator. I want to build a custom video cable later, but for now this one will have to do. And the machine powers up nicely and shows the locomotive basic boot screen. I'm going to test the tape drive as well, so I'll just enter a short basic program, save it on tape, reboot the machine, load the program and then try to run it. Time to reboot and load the program from tape again. If that works, the tape drive should be fine. And it actually does. So let's start doing some maintenance and cleaning on this thing. Let's open it up, shall we? The first steps are pretty easy, as the case is only held together by 6 screws. This plug connects the mainboard to the tape drive, the speaker, power LED and switch. The connector for the keyboard is huge. That's because it connects the whole keyboard matrix to the mainboard. There is no separate keyboard controller on the keyboard itself. It was a bit more difficult to remove, especially when you're trying to be extra careful not to break anything. Removing the mainboard is easy though, just a few more screws. Getting the tape drive out was a different story though, because there are so many small things connected to it. There was also a thumbtack hidden in the machine somewhere. I guess we were lucky not to short-circuit anything after all. The speaker and power LED were glued into the case, so I had to use a knife to cut the glue. But then I was done and could finally remove the tape assembly. This little spring pushes the tape door open and I removed them both together. There was also some dust between the transparent and opaque plastic parts of the trapdoor. To get that out of there, I had to separate the two, which was a bit fiddly, but in the end I succeeded. Before bathing the case, I wanted to protect the serial number stickers, so I put a bit of paper over it, which I then covered with Scotch tape. At that point, the case was ready for my typical procedure, a long warm bath. In the meantime, I started working on the keyboard. As I started to remove the keys, I realized that the metal base plate was actually pretty rusty. That's something I'll have to take care of very soon. I took the keys off the tape drive as well and put them all together into warm soap water for a few hours as well. As usual when taking the case out of the water, I gave it a good clean with a toothbrush to get the remaining gunk out of the seams and grooves. With the case and the keys clean, I began work on the keyboard itself. The base plate was pretty dirty and there were a few rusty spots that needed treatment. But first I had to get the keyboard matrix off. There were two plastic rivets. It was impossible to remove the matrix without breaking them, but they didn't seem to be very important for the stability of the keyboard at all, so I decided to just break them. The matrix itself was held in place firmly by a bunch of plastic clips. I was a bit afraid to break them, so it took me unnecessarily long to get the circuit board removed. Once that was done, it was easy to remove the rubber mats and the central moving parts of the keys, whatever their name may be. As usual, the first step in cleaning was to remove the dirt with water. That left me with a clean, but still pretty rusty base plate. I wanted to clean the rusty parts one by one, but for that it would have been necessary to get the plastic frames of the keys off the metal plate. And that didn't seem to be possible at all. The top and bottom seemed to be glued together, or welded, or even molded directly like that. I have no idea. And I asked around the internet, but apparently nobody knew how to remove them. So I thought I'd try an anti-rust trick I had used successfully several times. I wanted to soak the plate in vinegar so that it could dissolve the rust. And while that worked, it also removed most of the black paint or coating and replaced it with brownish slime. That was easy to remove with water, but the day after, the whole plate was rusty. But I wasn't sure if it was actually rust or just more vinegar rust slime that had crept out from between the plastic and the metal. If it was that slime stuff, it would be possible to remove it with alcohol. So I tried that and it kinda worked, but I couldn't get it all off. That was pretty annoying because it meant I had to use a wire brush and a Dremel to remove the stuff from between the keys. That was rather tedious work, and of course it still means I couldn't remove it all from between the plastic and the metal. So all in all, I cannot recommend the vinegar method in cases like this. Don't repeat my mistake, please. But in the end, I got most of the stuff removed and was left with a more or less clean metal plate, this time without black paint on it. But that also meant I was finally able to clean the rubber mats and reassemble the keyboard. I noticed this small spacer had fallen off, so I glued it back into place. In order to get the rubber mats flush on top of the plate, I had to put the plate onto a pair of spacers that allowed the center parts of the keys to sit in the frames without being pushed up. Reinstalling the keyboard matrix was easier than removing it, because breaking the clips is less likely when pushing and letting them snap into place than it was when removing the matrix. Using the photo I had taken before removing the keys, I began my favorite puzzle game of reinstalling the keys. As usual, installing the spacebar was a bit more fiddly, but on this keyboard it is the only key with a metal rod that keeps it level. I applied a fresh drop of grease to the rod and put the spacebar back into place. Now with the case and the keyboard cleaned, there's two more things that require some dusting off. The tape recorder and the mainboard. The recorder was working fine and it contained so many mechanical parts that I didn't really trust myself with taking it completely apart. Instead, I cleaned what areas I could reach with compressed air and alcohol. The same with the mainboard. Its top side was really dusty, the bottom more or less mint condition. I decided to also replace the only electrolytic capacitor in mainboard with a new one. This one is a decoupling capacitor for the whole power supply. When this one acts weirdly, the whole system will be affected. And it's about 30 years old now. This was the first time I had an opportunity to try out my new desoldering station, which I bought for a different project. So, the old cap has to go, and a new one of the same capacity but a higher voltage rating goes in. A higher voltage is no problem as long as the capacity stays the same, and I take care to use the right polarity. Reversing an electrolytic capacitor can make it explode, and we don't want that, do we? Then there was the issue of the weird power switch. It does its job, but it just doesn't look right. So it too had to go. I bought a bunch of these switches for my Amiga project. They are actually double pole, which means they could be used to switch two circuits, but we'll only use one, of course. With that all done, it's now time to reassemble the whole machine. I started by putting the window back into the tape drive drawer and the door back into the case. This little spring will push the tape door open unless it's held shut by the drive's mechanics. Reinstalling the tape drive keys was easier than I had feared. Just thread them through the opening, push the axle through, and don't forget the retaining ring in the end. The springs that keep the keys from rattling when moving the computer required a bit more fiddling, but even with my thick fingers I was able to do it. My new power switch has shorter brackets than the original one probably had, so I couldn't use any screws to hold it in place. Instead I had to use glue, but I think the result is good enough, and from the outside there's really no visible difference. All these small parts hanging from the tape drive that attach to the case are quite a nuisance, and I haven't seen any other computer design so far that is quite as intricate. I started with the volume knob and the power switch. Then the power LED and the speaker, which I also glued into place again. I don't think the LED really needs to be glued as it's held in place firmly. With that all done, all that remained was a lot of screws and a few cables, most notably the connection from the mainboard to the tape drive and to the keyboard. Of course, none of my refurbishment projects is really done without at least a short section about games for the machine, and this one shall be no exception. Sadly, I don't own any games for the CPC, but let's just say I was able to get my hands on a tape image of the game Cauldron. Image files for the CPC are called CDT files. Technically, they are exactly the same as tape images for the Sinclair ZX series, but with a different file name extension so that they can be distinguished. As a result, every tool that can work with the Sinclair's TZX files can also work with CDT files. The one I found to work best is called WinTZX and is for Windows. But it worked perfectly fine for me on Linux with Wine. So we open up that program. It's really easy to use. We just set the output mode to WAV files and then select the CDT file we want to convert. You can see the output as it immediately converts the file and writes the WAV file. Now we can open that file in any audio player we like. I chose Audacity so you can see the waveform. When we zoom in, we can actually see the data encoded as audio. Now all we have to do is connect the tape recorder to the sound card, insert the cassette and hit record. We wait a short while until the magnetic section of the tape is visible and hit play on the audio program. It can be a bit fiddly to get the recording levels right, but in my experience it's better to have it a bit too high than too low. Once the audio file is recorded completely, we can rewind the tape and move it from the tape recorder to the CPC's tape drive. On this old 464 model, it's enough to type run and a quotation mark to make it load the tape and run it. It asks us to hit play on the drive and then any key on the computer. So we do that. It starts loading the data and in the case of Cauldron and many other games shows a load screen while doing so. The process can take a while, actually exactly as long as it took to record the tape, just under 5 minutes for Cauldron. But once it's done, the game starts running. Now excuse my terrible playing, I've never actually played Cauldron before. I actually like the color palette of the CPC more than the one of the Commodore 64, but I guess that's a matter of taste. Well, I guess that wraps it up for this episode. I hope you enjoyed the video. If you did, please consider subscribing, liking or sharing. Thank you all so much for watching and until next time, bye!